Okay, now that we have all of the notation down, we get to actually start solving some inequalities. And we will use basically the same two rules that we used before when we were just solving equations, the additive property of equality and the multiplicative property of equality. There is one little thing that makes it different, so see if you can pay close attention to see what it is. Okay, let's see how inequalities work. Okay, first of all, just fill in the blank. What's the relationship between 1 and 3? I know it's easy, just humor me. Yes, 1 is less than 3. There's 1, there's 3, and 1 is less than 3. What if we add 1 to each of those numbers? Well, then I have 2 and 4. There's 2 and there's 4, and 2 is still less than 4. What if I add 5 to each of those numbers? Well, then I have 7 and 9. There's 7, there's 9. 7 is less than 9. I know this is easy, just bear with me. What if I subtract 7? Well, then I have 0 and 2. There's 0, there's 2. 0 is still less than 2. So no matter if I add or subtract the same thing to both sides, I preserve the inequality. So this is our rule. If A is less than B, then A plus C is less than B plus C, and A minus C is less than B minus C. What this really means is we can add or subtract the same thing to both sides of an inequality, and it doesn't change the inequality. Does it matter if C is positive or negative? No, it just means I'm shifting up if I'm adding, or shifting down if I'm subtracting. But if you notice on that last slide, the order of the red and the blue dot, they never changed. They just shifted up and shifted down. In fact, they actually stayed exactly the same distance apart. So we're going to solve this inequality just using the rule that's up there in red. If I have 2x plus 7 is greater than 10 plus x. If I'm thinking of my fence would go right through my inequality sign. So the first thing I want to do is expand parentheses, and there aren't any. There aren't any like terms to combine, so I want variables on one side and numbers on the other. So I'm going to move the numbers first this time. It doesn't matter which I do first. So I have 2x is greater than 3 plus x. Now I want all my variables on the left since I have all my numbers on the right, so I subtract x from both sides, and I get x is greater than 3, so we're done. We've solved 2x plus 7 is greater than 10 plus x. My answer is x is greater than 3. And I might ask you to graph it, I might ask you to write it in interval notation, I might ask you to write it in set notation, all those things you can do. We just solved it, and then we write our answer in one of the forms. So set builder would be the set of all x such that x is greater than 3. Interval notation would be the interval from 3 up to infinity. And the graph, well, I'd take 3, put an open circle or a round parenthesis, and shade all the numbers greater than it. So those are all just 3 ways of writing my answer. Okay, that is the additive property of equality. Let's do the multiplicative property of equality. Let's say that we have this same, almost same equation. Let's see if we can solve it just with what we know so far. Well, we know that we're allowed to add or subtract the same thing to both sides. So let's start out the same way. We'll subtract 7 from both sides. We get 2x is greater than 3 minus x. Okay, we want to add x to both sides. That's totally allowed. I can add the same thing to both sides. I can subtract the same thing from both sides. Now I have 3x is greater than 3. Now you're probably wanting to divide both sides by 3, but we don't have a rule that tells us that we can yet. Can we divide both sides by the same thing? Well, not yet. We can, but we have to be careful. So let's go back and just see what rule we have for multiplying. So we're going to start with 1 and 3 again, but this time we're going to multiply by numbers instead of adding numbers. So we know 1 is less than 3. We've got that so far. What if we multiplied both sides by 2? Well, then I'd have 2 and 6. There's 2, there's 6. 2 is less than 6. What if I multiply by negative 1? Well, the red 2 turns into negative 2, and the blue 6 turns into negative 6. There's the negative 2, there's negative 6. Who's bigger? Look at that, the inequality changed. So we do need to be careful if we're multiplying or dividing. What if I multiply by negative 1.5? Then I get 3 and 9, and all of a sudden red is less than blue again. 3 is less than 9. What if I divide by 3? There's my 1, there's my 3, back to right where I started, and 1 is less than 3. So what is our rule? Look at those for a minute. When did the inequality change, and when did it stay the same? Okay, we know that if A is less than B, then if I multiply by C and C is positive, the inequality doesn't change. But if I multiply by C and C is negative, that flips the inequality around. So if we multiply or divide by a negative, we have to change the direction of the inequality. Note that if we subtract, it stays the same. It's just multiplying or dividing. So now we have this equation. We went through, we subtracted 7, we go through, we add x. We come down to 3x is greater than 3. Am I allowed to divide by 3? Well, now that I have a division rule, I am. If I divide by 3, is it going to change the direction of the inequality? No, 3 is a positive number, so it keeps the inequality the same. So we get x is greater than 1. That is the end of the definitions, and we will do a lot of examples next.